everyone. I'm your host, Arun Wariku, and I would like to welcome again Ryan Chapman. Uh, hey, Ryan, glad to see you.
Yeah,
And
thanks for having me on again.
yeah, of course. And today we are going to talk about ransomware builders. Now, for folks who don't know much about ransomware builders, as the name suggests, are is essentially a software for building ransomware. It has significantly reduced the barrier of entry for uh, any enterprising cyber criminal. And has significantly increased the threats, like we discussed last time, Ryan, as you mentioned that not only we have RAS now, we also have these leaks that are just increasing the number of threats we are seeing from in terms of ransomware. So without further ado, I'm just going to uh, give it to Ryan, who is going to walk us through how a ransomware builder looks like.
Awesome. So yeah, the RAS groups, ransomware as a service, were some of the first to come up with the idea. Well, wait a minute, we can facilitate a turnkey business if we
Right.
simply just make this builder that allows us to build out different variants of their ransomware, provide it to their affiliates. Some of them even give the builders to their affiliates directly. It depends on the group. So I want to show people there's a number of places where you can check these out, but there's one place in particular that I really like to go,
Mm.
and it's a website called VX Underground, and they do a whole bunch of awesome stuff for the community. They archive malware, they do all kinds of amazing stuff. So
Right.
ignore the screen you see here. That's just part of the VM that I'm using. And as soon as I can get this right there, let's see, let's go take a look. So you can go to for528.com/VXUG, and it's
Mm.
short for VX Underground. And it should take you to the VX Underground. And then let me go full screen here. On this site, if you just scroll down, there's this part down here where they have a bunch of their malware. This is not their full malware repo. They have a very, very large one. But
Mm.
if I go down to, let's see if it's under archive and then builders. So it's just simply under archive and then builders is the path. And there's all these different builders here that you can look at, you can analyze, and you can learn from. I've shown this off a couple times, and I had a couple comments here and there on YouTube, like, "Why are you showing the threat actors where to get those?" Yeah, they know where to get
We
these.
already know that.
This is not where they're getting them from, by the way.
Yeah.
They know where to get these. So these builders are all the ones that have been leaked out. And
Mhm.
so, for example, like this guy right here that I'll highlight, Agent Tesla is a .NET based remote access Trojan, or RAT, and we see that often in incident response cases. And if you're wondering, like, well, how is that built? Well, there it is, right? And then on this screen, if I look for ransomware, I see like the Chaos Builder. Here, I'll grab this guy and just download that. Let's see. There's also, let me do another search down. There's Thanos Ransomware Builder. We'll take a look at that guy. And what else do we want to look at? There's Hakuna. Let me see if they have Babook on here. Yeah, they have the Babook builder. So this particular builder, the one called Babook, Babuk,
Mhm.
that was a ransomware group that was infamous for a while, a solid year at the very least. But they have offshoots into many, 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 many of the current day ransomware groups. And a big part of why we're seeing so many of those offshoots is because their builder was leaked. It was one of the earlier leaked builders from a more prominent group. Since then, we've had a couple others, like Lockbit is right here. I'll grab the Lockbit builder, and a couple more, but these are the two big ones, Babook and Lockbit, which have facilitated all these new groups that just like kind of sprout up, and all of a sudden they become their own group. And yet the code for their encryptor, when we reverse engineers get a hold of it, we go, wait a minute, that's not yours. I know what that is. That's something that we've seen for many years now. So if I just pop over to my downloads folder, I'm using a VM from my ransomware class just because it has all the tools that I'm
Yeah.
going to need, basically. So you see that I have these builders. You can see where I previously had downloaded the Lockbit builder
Yeah.
over here. And there's another builder that I would also like to show, because if people want to get their hands on a builder to understand truly how they function and be able to use them, one of the easiest to use is one that's based in Python. It's called RasNet, and I actually cover it in my class. For right now, let's just extract all these.
Mhm.
7-zip, extract to individual folders. and the password. Okay. So for example, if I were to open up the Chaos Builder, oh, they gave me a RAR file. That's okay. Extract it right here. All right. Survey says, check it out. So this is what a builder looks like. I'll make it go full screen. The text is a little fuzzy. That's just an artifact of how they wrote the sucker. But the builder allows the following. This first top part here, this whole part is the ransomware note. So I can change this. Oop, I actually spelled it correctly though. So this is where you would say your network has been impacted by the Arun and Ryan ransomware, blah, blah, blah. You get the idea, right? So this is where the ransomware notes typically notes go. Typically, a builder will either be configured via a graphical user interface, like the one we're looking at right here, or it'll simply be configured via a text file where they can just enter, make changes to a text file, and that will then change how the builder builds the ransomware. And I'll show you that coming up shortly here. So they would normally have things like, what website do you go to? Their weird onion sites, .onion, like go here in order to contact us, or email us at badstuff@proton.me. Proton is often used for ransomware. Nothing against Proton in general, but they're just very popular with ransomware actors. Yeah. So, it's a contact us here or something like that. Download Tor and then go here, click on talk to us or whatever it might be. Cool. So I have a number of different examples of ransomware notes if anyone's interested. If you go to for528.com/share, just the word share, like I'm sharing something, and then you can go down to I think it's example. Well, let's just find out here. Let's go to it. I want to show this part off because a lot of folks don't know what these ransom notes look like. So if I just go to the share, this is the share for my course, but it's all free stuff in here. So wait for it to load. It's just a Dropbox link. I host a bunch of stuff on this link. And you can go down to, I think it's example. Yeah, example ransom notes. No, I definitely don't want to sign in right now. Go away. So these are example ransom notes. No. From different teams. So like 8base became popular last year, 2023, that is. And if you're wondering, well, what does it look like when they use a builder or not, and they have a ransomware note that gets deployed into an environment, this is an example of their ransomware note. Away. So there you go. Dear management, if you're reading this, basically, right? So all of the notes that you can take a look at, oftentimes they're just simply dumped in here into the builder. And this particular builder for Chaos ransomware, down at the bottom left-hand side, and I'll zoom in here for you. There we go. So you can see that we have some options down here. Like we have randomize file extension. So you can randomize the actual file extension that the builder will use when the ransomware executes. In other words, the files would have a dot and then in this case a random file name. But if I wanted to make it like .Arun Ryan, like then you would put that in there. And then there's the option down here where do you want to try to spread over the USB and network? So do you want to try to make it such that, SMB connectivity occurs and then other machines are infected? And then we have other options over here, for example, like at the bottom right-hand side, and it's the process name under which the ransomware will run. So the process name, in this case, they chose as a default servicehost.exe. A lot of ransomware does that, by the way. A lot of malware does that. And that's because in Windows, the services.exe is the daemon handler that Windows uses for services that are running. And the processes that run underneath that context are typically called svchost.exe. They spin up, they spin down, they spin up, they spin down. It's very common in a Windows environment to see servicehost.exe running and then not running, and then another one running and then not running. So they try to hide, with legitimate name essentially, but they can change that to whatever they want. And then over here, the dropped file name for the README, read it, README, recover your files, whatever name they choose, that type of thing is all just basically entered right into there. Under the advanced options at the bottom left-hand side in this particular builder, I can go into here and then let me zoom in. So we can essentially try to make it difficult for administrators to recover. I think this is just a translation thing where it says resist for admin privileges. I
Mhm.
think it's more resist essentially admins doing what they need to do to get things back in working order. So we can delete shadow copies. We can delete the backup. That's the recovery backup catalog in Windows. So, if Windows fails,
Mhm.
I don't remember how many times it is right now. Is it 3 or is it 5? Something like that. Times in a row, it will automatically enable the boot recovery mode, which years and years ago, we're going to date ourselves. Back in the day, we would just hold F8, and to go into safe mode, right? But now it's after a certain number of failures occur. Well, we can basically disable that recovery mode completely and
Mhm.
delete all the backups, all the system restore backups, so that administrators wouldn't be able to easily recover, basically. And then you've got down here, like change the wallpaper. So I can just basically make a wallpaper, whether it says Arun Ryan ransomware, contact us here. Like just don't ignore this or whatever it is, and put that, and it will just change the wallpaper on that machine. And then over here, they have different types of encryption that can be selected. So these are just some general options for a builder. And if I were to change this to the file name should be Arun Ryan and network, I don't want to do network spread. The
Just
process
looking at
name
this, Brian,
is
it looks so intuitive and so easy for anyone to, create a ransomware.
right. That's the problem. And that's why we're seeing so many of these darn things.
Yeah.
But I'll just make some random changes and click build. Let me see if it's going to build in this environment.
Mm.
Looks like it might actually. What did I call it? Rutro.exe. Let's see if it actually saves it. Okay. So on this particular virtual machine, I have an improper build environment. So it actually gives me a C# error, but that's whatever, no problem. So it's going to give me these errors and not actually build, but it's just because the machine that I'm running on right now, I probably should have used a different machine because I forgot that this happens. But it's just going to keep erroring out. So I'm going to tell it to go away. And let's just see if I can kill the builder real quick. All right, we close it up. And yeah, so this particular one didn't build on this VM, but trust me, this builder works, and it works very well with proper .NET frameworks installed. I just didn't have mine. I'll just give you an example of one of the most basic graphical ones.
Mhm.
And the next thing I want to do is I want to show off the Lockbit builder.
Yeah.
So Lockbit 3.0 is currently, and for the past, the time is just passing by quickly, the past number of years now, they've been the largest ransomware group. They pretty much took the crown after the Conti ransomware group had a massive leak, like an internal leak. It wasn't just their builder, it was their source code, it was their chat and communications. I mean, it's a ton of stuff, by the way. And so they were like, whoopsie poopsie, and they shut down basically. After they shut down, when you look at the graphical numbers of how many victims there are, you used to see Conti was way at the top, and then the others would, kind of go down like this. Now you see Lockbit way at the top, and then
Yeah.
the others are, kind of close behind them. And I said kind of close. They're not really close, actually. Lockbit, they're doing a lot of work, unfortunately, not work that we like. So this builder is different. It's not graphical. This
Okay.
builder uses a bat file. The
Okay.
bat file is where you can configure how you want the build process to occur. That will invoke the builder.exe, which actually does the building. And inside of the builder.exe, there are actually resources. I won't pull into that right now, but there are resources which are a type of data point. I guess I'll just call it data that you can embed into a portable executable. In other words, a .exe, a .dll, whatever. And those resources are the different versions of the ransomware. They're encoded, they're XORed. When the builder runs, it pulls its own resources out,
Mhm.
looks at the configuration file on how you told it to configure the actual ransomware, uses the keygen file to create the keys, the private key and the public key, and then
Mhm.
it builds the ransomware. So the thing that makes this like seem really simplistic and just where you go, oh, I wish it wasn't that easy, is that what is ransomware when it comes down to it? What is the whole impact and why is it so difficult to deal with, right? By the time it runs, when it executes in your environment. Well, all it's doing is encrypting files using a private key. That's all it's doing, right? And the encryption methodologies, they vary between the different ransomware variants. Some of them use Cha-Cha's 20, some of them use Cha-Cha 8, some of them use just straight AES. Like they're all different in terms of how they perform the actual encryption. But what are you paying for if you actually pay for a ransom, right? You're buying a decryptor. Well, that decryptor is going to be created by this builder in this case. But what are you really paying for? What you're really paying for is the private key that's inside that decryptor, because that's what you need in order to decrypt all of your files, right?
Mhm.
Well, this one application over here, this keygen, which is 31 kilobytes, that's just a little guy, right? That will generate pairs, a public and a private key. The public key is shipped with the actual ransomware and it does the encryption, but it cannot do the decryption. You need the private key. So that private key is also, of course, generated by this little bitty program right here. So if I show you the build.bat,
Mhm.
you'll see that we have this current configuration. And the first thing that it's going to do, I'll zoom in even more. All right, that's a lot. Okay, I'll stop there. So let me just put a new line in here. What is it going to do? It's going to erase the contents of the current directory build folder, everything that's in there, right? So what is that? Well, that is this guy. There's a folder in here called build. Notice it's already empty, right?
Yeah.
But if I were to have built something previously, well, then it wouldn't be empty.
Mm.
So the bat file, the first thing it does is it just clears out that folder. The next thing that it does is it invokes the key generator. And actually, let me not highlight that because it didn't look good. That bluer highlight looks better. So to run it, it's simply just keygen the path, which is we're going to use that build folder. And then it says, go ahead and make a combination public private key. Call the public one pub.key and the private one priv.key. I can change those names here in the script, and then they would just have a different file name. But the file names are really pointless because what matters is the key that goes into that file, because that's your key that's going to decrypt all the things, right?
Mhm.
And then the next thing that we see is a number of different invocations of builder, which is builder.exe, before we have an exit. And these can be up to the ransomware affiliate and or the ransomware developer, how they want to deploy the ransomware. Meaning there's a couple different options. One of the options is, well, first and foremost, it's going to make the decryptor. So there's that. That's important. It's going to use the JSON file. It's going to take that private key that was just generated above, right? That's this guy right here that gets generated. And then essentially it's going to build the decryptor. And I'll show you what that decryptor looks like too.
Yep.
And the next thing is that you have 4 different versions of Lockbit ransomware. One of them is regular old Lockbit, lb3.exe, and I can change the name, of course, to that right here. The other one is lb3_pass.exe. So some ransomware has the ability to require a password when it runs, when it executes. And the reason that they do that is that if a reverse engineer like myself gets a hold of that, if I don't have that password, then I'm not going to be able to get it to run. And it's going to be very difficult because when it runs, it deobfuscates itself into memory. And that's how I would then analyze it. So they can choose to use a regular version. They can choose to use a passworded version. They can also choose to create a dynamic link library or a DLL. So it won't actually be a .exe. And rather, they would invoke that using run32dll.exe. They would then provide the name of the DLL that's created. Here's the default name that they shipped with their builder, and then the name of the exported function. And I would get that if I actually let it build in this manner. And then the last guy here is actually not the last guy, excuse me. The second to last guy is a DLL, but also with a password that's required on the command line in order for it to invoke. And it would tell me, hey, I generated a password. Here's the password. And then the last version is a reflective DLL injection methodology. Now, this one is a little more limited in features because of the way that DLL reflective injection works, but it's an option for them to try to bypass EDRs and things of that nature, endpoint detection and response, EDR, XDR, whatever it might be. So it's going to build by default all the different versions. So if I just close this file, right now the build folder is empty, right? There's nothing in there. And all I have to do is literally just double click build.bat. You're going to see a window pop up. It's going to build Lockbit ransomware, some of the most dangerous ransomware out there, and then immediately just go away. It's very quick. So I double clicked, done. That's it. I just built the ransomware, right? However, if I go into the build folder, as quick as that was, it's still empty. And that's because I have to go make some changes. So over here, there's my configuration.json file. I didn't open that yet. Let's go open that guy. I'm going to back up a little bit. And here you go. So they have actually, I changed my mind. I'm going to zoom back in there. So you have these configuration options in theirs, like for a botnet. So if they have a user ID or a specific key that they want to embed, they can put that here under the general config. And this is just standard JSON formatting. So very easy to manipulate, right? We have like, do you want to provide an encryption file name? Like, no, we're just going to use random names or whatever. Do you want to do a language check? And if we do a language check, if I were to scroll further down in here, let me just see if I can find it by language. Oh, I thought theirs was configurable. Ooh, maybe it's not. Maybe it's just looking for, scrolling down. Oh, I thought theirs was modifiable. Ooh, maybe it's not. So some ransomware will basically it has the ability to look at the keyboard layout. And that's what they say language check. It'll look at the keyboard layout and it'll see if there's a Cyrillic language that's been set, which is typically like Eastern European bloc. In other words, we don't want to encrypt our own. And so if you have the language check on, it will look and it will go, that's a Cyrillic keyboard. That might be Russia, for example, just saying. And then like, let's not encrypt that machine. Right. So there's a bunch of different options in here. Like, do you want to set a wallpaper? And then below there'll be a path to the wallpaper. Do you want to try to kill Windows Defender? Like, yeah, of course we do, because otherwise it might stop us. Do you want to skip hidden folders, or do you want to encrypt them also? You know, so there's all these different options that they have in here. And then they have these folders down here. This one's called white folders. And it basically means these are the folders that we want to skip, essentially, that we're not really worried about encrypting. And those are fully modifiable. You know, I just put my own in here, other folders, you know, whatever it is. And then if it finds a folder with that name, it won't try to encrypt it. And then there's files that we should skip, files that we don't want to actually encrypt, like boot.ini. They want the machine to be bootable so that the people could read the readmes and things of that nature. And then there's extensions to skip over, basically. So in this case, we're not going to encrypt BAT files or DLLs or OCX files or whatever. And then there's also hosts. This is just an example of host name I believe that they have in here. And so if for whatever reason they don't want to encrypt a given host or 2 or 3 or whatever, then, or 20, then they put the names of them in here and it will just skip over it. And then we also have kill processes. So they can add in any process names that they might want to kill. And these are just substrings of a process. So like if SQL is running, you want to kill that process, and you also want to kill its service, because if a database is actively running while it's being encrypted, there's a chance it will be corrupted and can't be recovered. And so sometimes you'll see them use that feature. And then let's see, they can impersonate different accounts. And then of course there's the note. So in this case, here's an example of Lockbits. It was one of their older notes, but they're still very similar these days. And I have examples on that network share I talked about earlier. So they like to give a bunch of different domain addresses in case 1 or 2 of them get seized or taken down or whatever the heck. And then basically that's pretty much it. So when they take all this stuff together, and let's see, mine didn't build the first time. So what I think I'm going to do is move it to my desktop. I'm going to try to build it for my desktop. That's usually where it works. Let's take a look. The build folder is empty. I'm going to invoke build.bat. I'll just run it as administrator to make sure. And done. There you go. It's all done. Now, why did it not build in my downloads folder? I don't know, but I couldn't even tell you. I don't know why I didn't. I was like, hey, it didn't build. That was weird. But you'll see here, I have the different versions of the ransomware. Like if I make my icons bigger, this is, I don't really want to click on it, so I'll just do this. This is the regular version. This is the one that requires a password. This is the reflective DLL. Well, you can see the names right there. Here's the decryptor right there. So in fact, here's what a decryptor for Lockbit looks like. I simply double click. This is it. Here, I'll zoom in. Look how simple it is. How many encrypted files did it find? How many decrypted files, was it able to do? So I click that button and it's going to use, I'm going to kill it right now. I don't want it to keep doing that. Whatever the information was that you put in the configuration, like in terms of encrypted file names and things like that, it looks for those on the system. And if it finds them, it uses the embedded private key and tries to decrypt it. That's all it is. That's all the decryptor is. It's nothing special. There's also this decryption ID.txt file that I get.
Mhm.
This is the password that you need to enter in for the passworded versions. Oh, I lied. This is the passwords are right here. Excuse me. The decryption ID is actually the decryption ID you have to get to the RAS team. This is kind of like your client identifier. That's what that is. And let's see what else. We have the public and private keys. Obviously, you wouldn't want to ship out the private key if you were the ransomware group because that could be a problem. And so it's as simple as that. I know that it can be very scary to see how quickly that builds. You just run the executable, like run the bat file, and that's it. That's all you have to do.
That's pretty much it.
So
A lot bit. Wow.
yeah, that's as simple as Lockbit ransomware is. And I have one more that I'd like to show. Okay, there's one more builder I'd like to show you. And the reason I like to show this one, it's also the one that I use in my class, is because it's based in Python. So rather than creating a very fast running little small, either like C or Go or Rust or something like that executable, this will actually create a very large executable because it includes the entire Python framework in order for it to run on remote machines. However, I like to show this one off because if you wanted to learn more about how the builder works at the core level, what you would have to do with these previous examples is reverse engineer them. You would have to open them up in IDA or Ghidra or look at the resources with some tool like CFF Explorer or some of the tools I have on my desktop, actually right here over in the malware tools, right? But you have to know how to analyze malware. Rather, if you're working with a version of ransomware with a family that is Python based, as soon as it generates the Python scripts, you can just open those and just read through the code. And even if you don't know how to write Python, like if you wouldn't say, I'm a Python programmer, I would never say that, but I write Python multiple times a week and I read it every single day. So it's very easy to kind of understand how it's working.
Mhm.
The first thing I'll do is I'll show you that it is here. This is where it's located. You can get a link to it at for528.com/rasnet. That was supposed to be an arrow. Let me do a better job at that. There you go. Now we have an arrow with a thick, a very thick arrow. So if you go to this site, and I think it's still up. Let's see. It is. Okay. It's
Mhm.
on GitHub. It's just sitting on GitHub. So the original repo was put on GitHub by the author. That was taken down, but this fork is now the primary one, and it's been up for I don't know how long now, for years now. So oh, actually, well, right here, at least 5 years. You can see it right there, right in front of me.
Yeah.
5 years this ransomware on GitHub. So Rasnet, I have this sitting on my machine because this is my course VM. So I'm just going to navigate to it. Give me one moment. And here it is. I had to make a version of it. I had to apply some changes, if you will. And I made a version called no login. And that's because the original version had an option to basically register an account in order to use it. And the servers that were providing the backend for that at one point were down. I was actually teaching a class and they were down. And I was like, no, we need to use this. What am I going to do? So I modified it's just Python, right? So I just modified it. So I can put in any name here, Arun Ryan, and I can put a password of whatever I just typed in, and I can hit log in and it logs right in. So this particular ransomware uses what they call a generator. It's the builder, right? This ransomware uses a server, and the server, I'm just going to invoke this locally. The server is basically what's going to be used to collect the keys that are generated because this guy does not use public and private key crypto. It doesn't use asymmetric keys. It uses a symmetric key that is generated when the ransomware runs on the remote host, and it gets a different key for each host that it runs on.
Mhm.
Imagine deploying this to 1,000 hosts and then having someone actually pay the money for it and then having to give them 1,000 different keys and then have them try. Oh, that would be a nightmare. But
Yeah.
anyway, so the default name for this is actually Demonware. You can kind of see it at the bottom of your screen, but if I copy all and I do this, give it a second. There you go. Let me zoom out. There. So this is the key server is now running. The key server is supposed to be running not publicly, obviously, or excuse me, not privately, obviously, but publicly. and they would bind it to a remote IP address, and then the feds would probably try to take that down, once it starts moving around. But I'm going to minimize this guy, and I'm going to minimize the key server, not close it. And then I can choose to generate a payload. It's as simple as that. So I click on generate payload, and look, we have another graphical based builder. And in this builder, we have a number of different options. I'll zoom in here. You have, do you want to run it in GUI or console mode, which is, there you go, right there. GUI is currently selected. You can also run it full screen. So I can make that selection. This is where you would put in the information for the key server. So mine's running locally right now on the default port. I'm just going to leave it like that. And then you have some other options like the encryption type. So do you want to use PyCrypto or PyAES? It's just different libraries for Python that are more performant than others, essentially. Simple as that. So another thing is that you have these other options over here. You can have it self-destruct. You can have it run as Windows admin, like these options over here. And then you have these options up here, which are very important. And I want to explain them, but I would rather explain them when we look at the actual code that's generated, the scripts. And I'll show you that actually very, very shortly. The other things you can do is set up like your custom message. So, excuse me. So up here, this would be where we have Arun Ryan Ransom. I spell it correctly. I did it again. And then you'd have, the domains or the emails or, sucks for you or whatever horrible message they want to give, and then you would save that. And then you can also do a custom image. So the image would be the wallpaper, basically. I'm going to skip out and doing that for this one. And then you can choose the file extensions that are encrypted. In this case, this is the opposite of Lockbit. Lockbit was like, tell me the ones you don't want to encrypt, whereas this one is tell me the ones you do want to encrypt. So if you look through this list, as an example, they have PPT and PPTX, they have doc and docx, but they don't have XLSX. So if I wanted to add that, I would add it like that. Or I could add docm also if I wanted to, whatever files I want to encrypt within that target environment. I hit save. So I've got a custom message. I have custom file extensions, and then I can choose the target directories. So in this case, I can choose the working directory. Like, what are we going to encrypt? We'll do the C drive or, whatever it might be. In this case, I'll leave it on home. And then you can choose the target directories to encrypt. Again, notice Lockbit took a much more aggressive approach. Whereas they're like, just tell me the few you don't want to encrypt. I'll encrypt the rest, basically, right? So in here, I can, for example, if I wanted to, I could just say, you know what? Just encrypt documents. That's all I want to encrypt. And then I hit save. And now I'm basically ready. So what is this going to do? It's going to show this custom message, right? That's a horrible custom message, but I'm just giving it a quick example here. And then the target directory is just going to go for the whatever user context it's running under, their documents folder. It's going to try to encrypt things that are in there. And what I'm going to do here is click generate, and boom, done. As fast as that. The screen now says that the payload and decryptor were successfully generated, and it shows me that I can go find them because they are simply Python files. And this is where I think it's really cool for people who want to really learn more about ransomware is go open those files. It's not done yet. It's not necessarily ransomware yet. It's just a Python script. That's all they are, right? The decryptor and then the actual payload, the encryptor. So if I were to then click compile payload, it asks me which ones. And I say that guy and that guy. And I can also give it a custom icon. So when it's on the desktop, it looks like a certain type of thing, Yeah. Before I do that, however, we're going to go to the folder and you'll see, let me sort by date modified. Here's our two guys right here, decryptor.py and payload.py. So if you're wondering, well, what does a decryptor look like for this ransomware? Well, if I build this, it's going to be a large program because it's going to use PyInstaller and bundle like all of Python that's needed to run on a machine that doesn't have Python at all. And then this little bitty script. It's going to be a big file. I'll show you what I mean. But if I open it in Notepad, it's as simple as this. This script, which is only 84 lines, is the totality of the decryptor. And you can see it's using AES. The decrypt function itself takes in a ciphertext and a key. The individual decrypt file is the one that basically opens the individual files and then passes it to decrypt. And then below that, you have the decryption key. This tool works by asking for the key. It says, hey, what's the key when I run the decryptor? And this is problematic because if you put the wrong key in and try to decrypt the files, it's going to potentially make it irreversible to ever retrieve them again because it's not intelligent. It's not going to say, oh, let me use this key and decrypt the data. Oh, look, there's the original data. It doesn't do that last part. It just goes like, decrypt AES routine, go. And if it fails, then oops. And you can select a directory. So this is where they actually like choose a directory. And then this is basically the runner that simply does the job. And so it's looking in this case for files that end in .daemon, right? If we wanted to change that, because that's the default for RASnet, notice there was no option in the generator to change it from .daemon. But what if I do Arun Ryan and I save this file, the decryptor? Readme.txt could be in the folder. And we're going to go ahead and close decryptor.py. And let's go take a look at payload.py. This is where you can see exactly how the encryption is done, basically. So we have a class in here called, let me zoom in a little bit. There we go. There's a class called main window. The title of that window is Tango Down. So that's what will be at the very top of the window. Notice the builder didn't give us an option to change that. But you know what? This is Python. So all I have to do is that. Done. And now my window title is going to be different. I'll save the file. And then we've got, this is a photo code. It's a base 64 encoded version of the screen that it likes to show when it's running in GUI mode. I can change that if I wanted to technically, or I can just leave it alone and scroll past it, which I'm going to. You'll see the bulk of this file is literally just dealing with the picture and then the message. That's all the way up to line 170. And there's only, let's see, how many total? 351 lines in here. So I'll scroll back up to the top. Here is where we have the array for, or I guess I should say the list or dictionary, because we're working with Python, but it's the array of the file types that I want to encrypt. So if I wanted to change those now, I could. I could change those. Another thing is I'm going to do a control F for daemon. And you'll see that right here is the encrypt file function. This is called after the files are identified that it wants to encrypt and are already loaded into memory. And here's the trick. The difference in the builder, let me go back to the builder. Remember this option at the top right-hand side? The two different types, override and rename versus copy and remove. What's the difference? It's the way that it creates the encrypted file. And if we look at the code, we can see exactly what this means. So if I chose the, let me zoom in a little bit more here. So this option right here takes a file name and a key. It's going to open that name with read binary format, and it's going to read the plain text from that file. Then what it's going to do is it's going to create an encrypted version of that plain text by calling the encrypt function. So it's going to read the data in the file. Say it's just called, invoice.xlsx. It's going to read the file here. Here, it's going to pass the plain text of that file, so just the data, with the key to the encrypt function, which is the one right above it. And here's where the actual encryption is done. That's it. That's all that's required for the actual encryption part itself. The other thing that we see down here is that we have, with opening the file, writing it in binary mode, we're going to take that file and we're going to write the encoded version into the file. So basically, we read the file, we create the encrypted contents in memory, and then we write that encrypted contents right back to the same file. Then we use os.rename and we rename the file. In our case, I used Arun Ryan, not daemon, right? So I can save that. Now, this option here is this guy, override and rename.
Yeah.
The other option, if I were to have selected it, what it does is instead of writing the encrypted contents to the same file, is it writes it to a brand new file that will have the extension, and then it calls OS delete to delete the old one.
Mm.
That's how some ransomware works. That's a horrible idea. It's great for us on the blue team or on the forensic side, because if you take 100 files and you pull their data out, encrypt it, write it to 100 new files, and then you delete those other 100 files. Whenever you delete a file, especially in a Windows New Technology File System or NTFS, which is most Windows installs around the world, if you delete a file, there's something called the master file table, and it simply gets updated by saying, hey, remember that file right there that lives over here on the disk? That's not there anymore. It doesn't actually overwrite the file. So
Mm.
we in forensic land can go and we can recover those files, or we can attempt to recover those files if they haven't been overwritten by other newer files on the systems. Point being is that I just wanted to show that this is the override and rename. Most ransomware works that way these days. And by using this Python version, you can literally see exactly how it works. And it's very, very handy. Some other stuff here is it has the code in order to interact with the platform that where it sends the key out. And that's pretty much what I wanted to show you. Here's where it's looping through in order to find which files it wants to actually encrypt in order to pass them to the encrypt files function. And that's enough of that. So what I'm going to do, wait, maybe that's not enough of that. Let me go back to that guy. Hold on. Are there any other instances of daemon? No, it was just the one. All right, good.
I mean, it
So,
blows my mind looking at the Python script and seeing that a Python script could be used for creating a ransomware general.
right? It's so simple too. The lines that do the encryption, was it 4 or 5 lines? Like it's so easy. So I'm going to choose the compile payload. And when I do that in the background, it's now compiling the ransomware. Now, remember when we ran the Lockbit builder and it went like that? Remember when it was super, super quick? This is not going to be super quick because it's basically running PyInstaller and it's taking like a ton of Python runtime information and then shoving it into an executable and then making it so that when it runs our script. In this case, the encryptor or the payload. So we just give it another minute or so and it should be done. Here's all the PyInstaller stuff happening. And very soon here, it's going to pop up and say that it's ready. Right now, it's building out the final package. And it's going to say, basically, do you want to also compile the decryptor? And then we can choose yay or nay on that. And we'll choose yes to go ahead and do that. So here's the final phase. We're in the distribution directory. It's going to create the payload.exe file. I'm going to pop over here, check my compile window. I'm going to check. Oh, there it is. All right, so it's done. And now it's asking, do we want to compile the decryptor also? Yeah. So now it's going to do the compilation of the decryptor. So what it's done is if I go over to this directory and I go into dist for distribution, I've got ignore those. Those were old. I should have deleted them before. We have our payload.exe. That's our ransomware. In this case, it's 23 megabytes. It's large because it includes Python, basically. But it sounds like it just finished our decryptor. So I will go over here. There he goes. And it says, all right, we're done. So I have my key server running. It's running here. And I have the encryptor and the decryptor on the desktop. I'm going to minimize some windows here. All of you go away. I'm going to take these guys and put them on the desktop. So here is our payload, and then here is our decryptor right next to each other, just kind of hanging out. So we told it to encrypt files in the documents folder, right? So I can go into documents, and we have some things in here. Like we have a folder called development. and inside of which we actually have RasNet. I just copied RasNet into there. We also have a folder called posters, and I have some of our SANS forensics posters in there, right? So when I run the payload, key server is running, run the payload, it's going to show a screen that basically tells the user, I can't tell if I double clicked it or not. I'm not sure that I did. I feel like I didn't. Now I did. All right, so now it's starting the encryption process and it's going to pop up the GUI. There it is.
Ooh.
So here we have the window. It says Arun Ryan ransomware. Sucks for you. Time left, 600 hours. And then over here, you'll see now we have a README sitting in documents. And if I open up the README, that's the README that I put together randomly, very quickly. And then if I go into this development folder, you'll see that we have like requirements.txt and then arun.ryan.
Ooh.
And if I were to open that and try to read it, it's all garbled. Now you'll notice that what it didn't encrypt are like YAML files and Python files and Markdown files, but many ransomware variants these days will actually encrypt those. We could have added those as custom files. I just left that part off. If I go into posters, you'll see that all 3 of my PDFs are now encrypted. If I try to open one of the PDFs and just look at the text, it's all encrypted, right? Very high entropy. PDF files, by the way, are textual in nature. You can open them in a text editor and read quite a bit of it. I'm not sure if people are aware of that. So I want to go check my key server. And I see it down here at the bottom. The window's a little big for my resolution, so I'm just going to copy it all and then put it in here. And then here's what it did. So here's the date and time from when we're recording right now. So now people know. Here's the username, the type of OS, this is the name, and here's the important part, the key. So this key, I'm going to put this in another window just to make sure I have it. That key, if there's a failure between when the ransomware runs and when it sends a key to the key server, whoops, it's going to be a big problem, right? So I have my key. I can take that key. And for example, let's see remember these PDFs that I can't do anything with now because they're encrypted? If I run the decryptor, it pops up and it says, what's the key? That's the key. And I hit OK. Then it says, pick a folder. I'm going to choose documents. It defaults to documents, which is nice because that's what we encrypted. I select documents and it says, hey, are you sure you have the right key? Because if you don't have the right key, like you're going to have a bad time. Like you're not going to be able to get that back. One of the examples as to why I recommend that people back up their encrypted files that are like super critical if they don't plan to pay for the ransomware, or even if they do. Because if you try to decrypt and something messes up, like that data is just going to be useless at that point. So I say, okay, and it runs. Uh-oh, it named it AR instead of PDF. I wonder if it actually decrypted it properly. Survey says it did. Okay, I must have named something stupid in the decryption script. When I changed it from Daemon to Arun Ryan, I must have made a boo-boo. But either way, you get the idea. It's now decrypted. If I open it in Notepad like I tried before, there we go. PDF 1.4, cross-reference table. Here's my objects and lists in the PDF. If I scroll down, oh, well, this is a large PDF. Maybe I won't scroll down. Yeah, there's still a bunch of binary data in here, but you get the idea. It's decrypted now, and now I was able to double click it and read it. I just messed up the naming because I was doing it live. Do it live. So that's it. I wanted to show people that. Again, that's called RASNet, RAASNET. It's very useful for learning about how the encryption itself works and how the decryption works, and I highly recommend taking a look at it.
Yeah, amazing. This was really an eye-opener for me as well. I think we can now look at RASNet and learn more about how ransomware works, especially looking at Python. It was really, really interesting to see that. Great. So, yeah. So today we learned a lot about how to build and talk about ransomware builders. And I would like to thank Ryan for taking us through ransomware builders. This was really great, Ryan.
Good. Thanks for having me on again. I appreciate it. And hopefully folks learn some things and, go out there and learn even more because we need to stop ransomware as much as possible. And the only way to do that is to truly understand it.
Absolutely. Couldn't agree more.